Okay, lesson 4.8, solving problems with trigonometry. Okay, so sine, cosine, and tangent, using those to solve word problems. A little bit of vocabulary before we get started. Angle of elevation, angle of depression. Are you guys familiar with what that is? Angle of elevation is going to be what? As you look up. So an angle of elevation could be as you look up to the top of a building. So as you're standing on the ground and you're looking up. What about angle of depression? Down. That's looking down, right? So that's more if you're standing on top of a building and looking down. Okay, so understanding that vocabulary will help us be a little more successful. So in here, the angle of elevation, angle through which the eye moves up from horizontal to look at something above. Angle of depression, the angle through which the eye moves down from horizontal to look at something below. Okay, let's look at example 1. The angle of depression of a buoy from the top of Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. You got me. Let's draw a picture. My pictures are not going to get fancy. You guys know that, but this building, I'm not even going to try and draw anything fancy, is going to be my lighthouse. Okay, so there's my lighthouse. What do we need to know? What do we need to draw with this lighthouse? With a buoy, right? Where's the buoy? The buoy is the thing out floating in the water, right? So I'm going to make my buoy a point out there. Keep in mind, this is water level here, yes? The buoy's at water level. The base of the lighthouse is at water level. Now, what do you think we're going to create here in this picture? A triangle. Do you see the right triangle happening? Okay. We've got a right triangle happening. It says the angle of depression of a buoy from the top of the lighthouse. So from the top of the lighthouse, the angle of depression from the top of the lighthouse, 130 feet above the surface of the water, is 6 degrees. So, okay, what is that 130 feet? Height of the lighthouse. Okay, there's my 130 feet. Angle of depression of a buoy from the top of the lighthouse is 6 degrees. Where is that 6 degrees? Okay, kind of. If you look up in the directions about angle of depression is the angle through which the eye moves down from the horizontal. So if I'm moving down 6 degrees from the horizontal is okay if I'm looking straight out. Okay, not looking down, not looking up. Angle of depression then is going to be going 6 degrees down. So my 6 degrees is actually not in the triangle. It's between the horizontal and the triangle. And what are they asking me to find? Okay, distance from the base of the lighthouse to the buoy, so the bottom side of the triangle. Okay, so what do we have to know here? What? What has to make 90 degrees? Okay. Okay, they are complementary. Okay. These two angles form a right. There's two ways you can look at this. And this is the way that works more for you guys. I'm going to show you a geometry relationship, remind you about it here in a moment too. But one option, India solved the option that, 6 degrees and this angle here have to equal 90 degrees. And so one option you could say is that this would be 80. for, wow, 84 degrees. Now, there's another option.
And then it's the opposite angle of 6 by the buoy.
This angle right here by the buoy is 6 degrees. And that's more the angle I'm going to use. Although, honestly, I guess it doesn't matter. You could have used either or. Here's the geometry. I think geometry is what I want to say here. 2 parallel lines. Is this geometry? I think it is. I remember talking about pre-algebra a little bit actually at one point in time, but okay, no. 2 parallel lines. A transversal, so parallel line, transversal. These angles are alternate interior angles. And alternate interior angles are always congruent. Okay? I think I have the right vocabulary there when I say alternate interior. Okay? They're alternate sides of the transversal. And they're interior because they're inside the parallel lines. So yes, I have my vocabulary right. I just had to process it through. Okay, so did we have to go the direction of 84 degrees? No, you didn't have to find that. But could you go that direction if you want? Yeah. The point that I would say is if this one's 6, then this triangle or this angle down here is 6. Okay. How could I do this problem? SOHCAHTOA. How's SOHCAHTOA going to help me? Okay. I'm going to argue we can't use anything with sine or cosine. Why can we not use sine or cosine here? We never know a hypotenuse. We never know a hypotenuse. We're not trying to find a hypotenuse. So you're going to have to use some kind of tangent or cotangent thing. Okay. My brain tends to go tangent. Tangent of what? What do you want to do here? If we use this angle, tangent of 6 degrees. Tangent of 6 degrees is what? 130 over x.
And then
yeah, I think of it as times by x to get x out of the denominator. So if I'm timesing by x to get x out of the denominator, it becomes x times tangent 6 equals 130. To get x by itself then, divide by tangent. So 130 divide by tangent 6 degrees. Check your calculator usage skills about this point. First of all, I need to make sure that I am in degrees. And I'm there because we just did that degree problem a moment ago. 130 divided by tangent of 6 degrees. My calculator will do this fine and I won't need parentheses, I think. Some of you maybe put it in as a fraction, but it should work. Yeah. So 1,236, and I'm going to go 2 decimal places. So 1,236 and 8,700 feet. Realize you could have used cotangent. Okay, gotten the x on top. Could we have used the 84 degree angle? Yeah, you can. So there's not just one right way to set this problem up, but something involving tangent or cotangent would be my argument. That one was a pretty easy one. That one was a pretty easy one. It wasn't tricky or anything. Okay. From the top of the 100-foot tall Altgate Hall, a man observes a car moving toward a building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? There are 2 triangles involved here, yes. Okay. Again, I'm going to argue that you need a picture here, right? You need an appropriate picture. I'm going to draw my building over here. This is the Alt-Get Hall or whatever it is. I have no idea how to say that. So, now, from the top of the 100-foot tall Alt-Get Hall. So I know this right here is 100 feet. A man observes a car moving toward a building. So where's the car? Okay. The car is, the way I have mine drawn, over here, yes? And which direction is it going? Towards the building. So we have 2 points of observation, right? We have a point, say there, and we have a point as this car is moving. Okay. As this car is moving this way, we have another point of observation. And so we have information about the car in 2 different locations. Does that make sense? So that's kind of the gist of the picture. Do you see the 2 right triangles we can use?
Yeah.
Okay. Now let's see what we can label. From the top of the 100-foot hall, a man observes a car moving toward a building. If the angle of the depression of car changes from 22 to 46 degrees. Now, one thing I'm going to do, I'm going to draw my horizontal. Okay, so the angle of depression of the car changes from 22 to 46. So what is that 22? Okay, the car starts here, yes? And so the 22 is right there. 22 is right there because that is the first time it sees it. While I'm here, what's that 22 correlate to down below? The smallest angle out here? That's 22 degrees there. Now it changes from 22 to 46. Where's the 46? Okay, so this 46 is down to the second location. Okay. Where's 46 down below? It's inside this other triangle, right? So this right here is 46 degrees. Now, the key is, how far does the car travel? So what am I being asked? Okay, what's the distance between these 2 angles right here? That is what I am being asked. I'm going to call it X. Okay, I'm being asked X. Now, in order to find X, what's going to happen? Because is X a side of a right triangle? No. X is the distance between 2 right triangles, so to speak, but it's not the side of a right triangle. Have to find what?
The degree right there, like on the right side of the second.
No. I'm not going to need that degree. I mean, we could find it if we needed to, but I don't need it. Cole, you mentioned something about subtraction earlier. You see it? Yeah. You're going to have to find this whole distance, so all along the biggest triangle, and you're going to have to find the shorter distance along this inside right triangle and subtract them. Okay? I'm going to do a little bit more labeling. I don't know. I think I got my picture too low here. I'm going to call this whole distance Y, so when you look at later, and let's see, I'm going to call this short distance here D. So I have X is what I'm trying to find. That's my goal. Y is the whole big triangle. I'm using D for the smaller triangle. How can I find Y? Y represents where the car initially started up to the hall. How can I find y? Tangent of 22. Tangent of 22 degrees. So here's 22. We're looking at the whole big triangle. Opposite over adjacent. So we're going to have 100 over y. So if that's the case, multiply by y, and then divide by tangent. So y becomes 100 divided by tangent of 22 degrees. Make sure you're in degrees, of course. 100 divided by tangent. Now, honestly, I'm just going to leave that number on my calculator because I can always grab it, right? Now, I am going to write it down so I have it in my notes, but it's 247.5086853. Of course, it wouldn't stop there. That's y. Now, what do I need to find? Can't find x yet. I'm going to have to find d first. Because I need to know d represents the bottom side of this right triangle. So I can find d. How can I find d? This is going to be tangent of 46. So we're using this smaller triangle here. So tangent of 46 degrees is opposite over adjacent, 100 over d. So d is going to be 100 divided by tangent of 46 degrees. 100 divided by tangent 46. 96.56, so on and so forth. So 96.56888748. Excuse me. My goal was to find x. How am I going to find x? Okay. X is going to be y minus d. Honestly, if you wanted to type it in by hand or your calculator, it would just be, making sure you have enough numbers there. Or, if you still have them on your calculator, 247 point whatever minus 96 point whatever. Minus because we're trying to find x, and we know the whole length, y, and we know the partial length, d. Okay. And so I got an answer of 150 point, I'm going to round it to 94, 150 and 94 hundredths feet. Approximately. Okay. Okay. One last one. Okay, this time my job is to find theta. What relationship do you see with theta and the given sides? Okay. Tangent of theta equals 25 over 62. Opposite over adjacent, right? Okay, so that was TOA. Tangent is opposite over adjacent. Now, do you know what to do?
Yep, that's it.
Now we have to define theta. I want theta equals. Now? Okay, so we need to... Well, but you still don't know an angle, though. Even if you figure out the hypotenuse. You're still not going to know an angle. Okay, so, inverse functions. What do inverse functions do?
Flip it.
They flip X and Y, yes?
Yes.
So what's tangent inverse going to do here? Flip it. Meaning, tangent inverse of 25 over 62 equals theta. Inverses flip your X and Y values. Or in this case, my degree value. And so what I know here is that tangent inverse, we had tangent, but we need to find theta. So use tangent inverse to flip them. Can you punch this in a calculator? Yeah. Again, make sure you use the tangent inverse function. It's right above tan, so second tan, and it brings up a tan to the negative 1. Okay, that's when you have tangent inverse. And then in this case, you can type in 25 divided by 62, or you could do your fraction, 25 over 62. Everything's been degrees today, so I'm going to go with degrees still, which means mine is 21.96. You might be in radians if you have something different. But at that point, go up, and then you can just re-enter the problem, you know. And so 21.96 degrees. And I don't remember if the book says find it in degrees, or it's just because we're not really talking radians when it comes to these type of problems. You don't say you have an angle of depression of pi over 6, you know. That's all the notes.
I thought the rest of like the next 4 pages was part of it.
I did too. I was like, we are going to be on this.
No.
I always care about that.
Okay, page 393, 1 through 16, 19 through 24. We've got a couple minutes.